morning. Today we'll be seeing about database management system Unit-IV transaction management. So transaction, here we will be seeing about what is transaction concept, transaction model, desirable properties of transaction. It is also familiarly called as ACID. So transaction is a logical unit of work in a database. It consists of sequence of operation read and write that together forms a single task. Example, bank fund transfer. For example, from account A you want to debit 500 and account B you have to credit. So both must succeed together, otherwise they roll back. That is, both operations should be done. If one operation is done, if another one is not done, then it has no meaning. So it is inconsistent. So the inconsistency should not be there. The operation should occur, otherwise it should revert to the previous. That is called rollback. Groups multiple data operation into a single unit. Again about transaction. Maintains data consistency even in case of failures. Can be executed concurrently with other transactions. So transaction concepts, database operations. Normally in DBMS, the transaction is related to database, whatever you are doing the operation in the database. So you are reading the value of X, similarly you are writing the value, updating the value. That is called write operation. Reading means read operation. States of the transaction: active state, partially committed state, failed state, abort states. Active state, the transaction is executing, whether it may be a debit operation, credit operation, or money transfer. When you are doing that operation, it is called as an active state. Partially committed state, the final statement executed, but change is not yet permanent. So the thing is that the updated information will be in buffer, it will not be stored in the database. Committed state, that the changes will be moved to the permanent, will be moved to the storage. Failed state, when error occurred cannot proceed. That is called as a failed state in case of system failures, like that. Abort, changes roll back when transaction restarted or killed. So normally abort will be done if any transaction fails. Similarly, in the initial stage, one or two transaction states, when it fails, then you can recover with the help of the abort, or you can roll back. But if the transaction is most probably 80%, 90%, it is in the stage when the failure occurs, then the abort will be the costlier one. For that, there is a separate concept called as deferred log and immediate log. With the help of the log information, they will be recovering. So example you can see here in this states of transaction. Transaction T1 transfers 1000 from account A to B. So read operation, you are reading the A and you are subtracting 1000 from A. Similarly, you are adding that 1000 to the B account. And finally commit is the permanent storage. Transaction model defines rules and behaviors of transaction in DBMS. Components: operation, read and write. Atomicity, all or none property, whether the transaction should happen or it should not happen. That should be important. That is called as an atomicity. Isolation, no interference between the transactions. Durability, once committed, effects persist. Schedule, a schedule is sequence in which multiple transactions are executed. Example, you can see the types is serial schedule, concurrent schedule. Transaction executes one after another is called as a serial schedule. Transaction interleave operations, both are done. First A transaction schedule will be done, B transaction schedule will also be started. So like that is called as an interleaving. That is called concurrent schedule. Serializability, a concurrent schedule is correct if it is equivalent to some serial schedule and ensure consistency. So normally the problem arises in the concurrent schedule. Serial schedule, the problem will not arise because one after another. First transaction has to be done and then second transaction has to be done. It will not create any problems. Whereas in concurrent schedule, it leads to inconsistency that has to be taken care of. Some of the desirable properties of transactions: ACID, it is also called ACID, atomicity. All operations in a transactions are executed fully or not at all. Example, if a bank transfer, if debit succeeds but credit fails, roll back the debit. So this is the important thing. So you are debiting some account and you are transferring the money. Think that the failure occurs, the money is not credited, so immediately you have to roll back the debit operations so that the original state will be maintained, otherwise it will be inconsistent. Next, consistency. A transaction must transform the database from one consistent state to another state. Sum of the balances in all account must remain same before and after transfer. This is very important. This is the condition for checking the consistency. Any operations, you have to check the previous balance and after balance. If both are same, it will not a problem. If there is any deviation, then there is you can say that it is inconsistent. Isolation. Concurrent transaction must not interfere with each other. If two customers withdraw money simultaneously, balance should remain correct. So for example, two customers are reading the account A. First schedule, think like this: A reading the amount, and then B is also reading the amount. If two customers withdraw money simultaneously, balance should remain the correct. So the final balance you have to check, it should be same. That is the isolation property. That must not interfere with each other. That is very important. Concurrent transaction must not interfere with each other. Durability. So once the transaction is committed, its changes are permanent. Even if system crashes, achieved through logging and recovery technique. That we will be seeing later about deferred log and immediate logs. Types of failures: system crash, power or system failure, transaction error, invalid input or deadlock, disk failure, storage corruption. Recovery mechanism: undo and redo. Reverse the changes of failed transaction. Reapply committed changes after crash. Undo means revert the changes. Redo means again you are doing. Reapply the committed changes. So normally undo will be done in case of any failures, and redo will be done in case of failures which is very short. So after a transaction starts, if anything fails, then you can perform undo and you can perform redo also. But if the transaction is long and if there is any failure, then performing that undo and redo is a costlier one. Concurrency control. Multiple transactions may execute concurrently, possibly conflicts. So problems: lost updates, two updates overwrite each other, dirty read, reading uncommitted data, unrepeatable read, same query returns same result, phantom read, new rows appear in different queries. Solution: locking, timestamp ordering, two-phase locking. So the above problem can be resolved by using the locking, that is the two types of protocols: two-phase locking protocol and timestamp based locking protocol. So case study, you can see bank transfer. Transaction 1 transfers 500 from A to B. So first operation, reading the A, debiting 500 from A's account, writing to A account, so that if lesser 500 will be returned. And similarly reading B account, and you are adding B with 500, so 500 will be added to the B account. Finally commit. Transaction T2, check the balance of A read A, display A. If T2 runs before T1, may see the wrong value. Isolation property prevents this issue. So that is the transaction T2 for checking the balance should be done after T1 only. Before T1, that before commit of T1, if it checks, can see only the old values. Example scenario, you see, consider data item A, account balance with initial value 100 and 2 transaction. T1 deposit 10, T2 withdraw 5. You are reading the value of A, adding 10, writes A. Reading the A value, T2 transaction, subtracts 5, writes A. And this is a sample schedule for that. You can see here. It is a serializable schedule, one after another. Here the transaction T1 first reads 10. It wants to add 10 to account A. So it will read, first A will read the initial balance thing that it is 100. It will read A and it will add 10, so 110. So 110 will be written right. After write operation only the second transaction starts. It will not create any problem in this schedule, one after another. And here you see it is a non-serializable schedule, that is conflict serializable schedule. Here you can see that reading A by transaction 1 starts in the first stage 100, and transaction 2 also starts, it also reads 100, it is not 110, 100 again. And after that the transaction T1 adds 10, so that 110 will be there, and similarly it will write 110. And then here you can see the transaction T2, because of interleaving, it creates a lot of problem. So again A minus 5, so 110 minus 5, 105, and it writes back to the database. So interleaved differently, it could lead to inconsistent state. This is the non-serializable schedule. A non-serializable schedule will have an interleave operations, that is reading performed in T first, and then reading performed in the read 2, and then operations of T1, and then operation of T2, like interleaving. So in this case you should be very careful that inconsistency will prevails. For this example, the inconsistency will not be there, because even though it is interleaved, the operations of, and then you have to check the balance of after T1 what will be the value, after T2 what will be the value. So if you check, then it is okay, then you can say it is not in inconsistency state. But in some cases, when you are ordering like this, interleaving like this, it leads to inconsistency. Thank you.